Alright, we are going to solve systems today, which we've actually already done. We've actually already solved systems 3 different times. How did we do it those 3 other times? There was graphing. Yep. Oh, maybe. There it is. There was graphing. What was the other ways? Elimination, and I heard substitution. Good. Okay, so we have already solved systems these ways. Okay, so what was the point, guys? Please stop talking. What was the point in solving systems? What were we doing? Okay, to find what my variable is, my x and my y. How did that relate to the graph? Where my lines crossed over, right? Where those lines intersected. There you go. What were possible answers? You could get a point. What else could you get? There were 2 special cases for my solutions. There could be no solution because my lines are parallel to each other. What else could have happened? Infinite solutions because it is the same line. Okay? So do you think those options are going to come up again? Yes, it's still possible, okay? Because we're still, our goal is still the same. We're just going to solve it a different way. All right? So we're going to put everything together that we've done with matrices. And then tomorrow we're going to use word problems. So each day we've added one little thing. So today I'm giving you the equations. What do you think we're going to do with word problems tomorrow? You're going to have to make the equations and then solve. Okay? So we've added a little bit each day. So when we do a matrix, okay, step 1 is to find the determinant. We did that Tuesday of matrix A. Step 2 is to find the inverse. That was Wednesday. Then multiply. That was last week, right? All these things we know how to do. Okay? When we're talking about matrix A, matrix B, whatever, it comes from our matrix equation, which comes from our system of equations. Look at that first one. 2, 3, 5, and negative 2. Where are those coming from over here? Yeah, the numbers in front of x and the y's are my coefficients, right? That is matrix A. Matrix X is our variable matrix in the middle. So what variables are being used? X and Y. And then matrix B on the end is our constant matrix. It's what we're equal to. Okay? So if I have matrix A times matrix X, and it's equal to matrix B, and you're trying to get X, right? We're solving for X and Y. Looking at that, how would you move over matrix A? Right now it's A times X equals B. You have to divide, right? We don't divide matrices. We don't divide matrices. Remember, we do the inverse instead. You want to know why? Why? Let's think about it. If I divide by matrix A, do you agree that if I do this, using my law of exponents, if I bring this up next to B, that exponent becomes a negative 1? Remember those law of exponents? Remember, like 1 over x squared was the same thing as x to the negative 2 power? Remember doing that? Remember that? Same rule applies. So dividing by matrix A is the same thing as multiplying by the inverse, which is that negative 1 power. That's why we use the inverse, because we don't divide matrices. Okay? Multiplying by the inverse is dividing by a matrix. Same thing. Okay? If you have a graphing calculator, you can plug in matrix A, you can plug in matrix B, and then tell it to do A inverse B, and you'll get your answer right every single time. Okay? True story. Let's do a couple of them. You ready? No? How about now? While you're getting ready, let me ask you this. Remember how you said no solution and infinitely many? They could show up again? Yes. When do you think we would get no solution? When what's 0? Right over here. The determinant. Remember if we did our determinant and it was 0, we could not find the inverse? So if you can't find the inverse, is there going to be a solution? No. So if we get a determinant of 0, it's because our lines are parallel. All right, let's do one. Ready? I was very nice and gave you all these nice little blanks. That is not going to happen all the time. So don't get used to it. You will have to do this. Step 1 is to take your system of equations and create the matrix equation. So what's going to go in that first matrix? Good. Make sure your variables are stacked. Okay, make sure they're in the same order. If your second equation, your x's and y's are mixed up, you need to move them. Okay, they need to be stacked on top of each other. All right, what is my matrix X going to be? Just x and y, good, because those are my variables. And what is matrix B? 4 and 3. Good. Okay, so we've set up the matrix equation. Step 1, find the determinant. So how am I going to do that right here? 5 times negative 2. And then what? Which is negative 10. Yep. And then 3 times negative 4 is negative 12. So what is negative 10 minus negative 12? A positive 2. Positive 2. So what does that tell me about my solutions? Are we going to have one? Yeah. Good. It's not going to be none. That is correct. Okay, we will have a solution. All right, let's find our inverse. So yesterday, 1 over our determinant, so 1 over 2. Remember our flip-de-do matrix? What's our flip-de-do matrix? What happens with A and D? A and D switch spots. Good. What did you do with B and C? No, you changed their signs. Be careful. Well, no, because here, negative 4, if you said make it negative, it already is. So you got to be careful. So change their sign. So it becomes positive 4 and negative 3. All right. Nope. Now multiply it through. What is 1/2 of negative 2? Negative 1. What is 1/2 of 4? What is 1/2 of negative 3? Negative 3 halves or negative 1.5. Same thing, yep. And what's 1/2 of 5? It'll be positive 5 over 2 or 2.5. Good. You can use fractions or decimals. I don't care which one. Okay. All right, we have my inverse. Now, what did I do? Oh, I see. Yep. Hold on. There we go. Negative 3 over 2 is negative 1.5.
Yes, but you saying 3 over 5 is right.
Oh.
I said 1.5.
Okay, moving on. So we have my determinant, we have my inverse. Now we have to do my inverse times matrix B. So my inverse matrix was negative 1 and 2. Negative 3 over 2. 5 over 2. What was matrix B? 4, 3. Alright, we're going to multiply it. So first row, first column, that gives me what? Negative 4. And then 2 times 3 is positive 6. What is negative 4 plus 6? Uh-huh. Second row, first column, becomes negative 3 halves times 4, which is negative 6. Good. And then 5 halves times 3. 15 over 2, which is also 7.5. Yep. What is negative 6 plus 7.5? 1.5. Or you could also say 3 over 2. That's the same thing. So when I graph these two lines, where are they going to cross over?
2, 1.5.
2 and 1.5. How do you feel? How do you feel about this problem?
Wait, I know this is a dumb question, but how'd you get like the 6 and 7.5?
I had to multiply my first row and my first column.
Oh, no,
Or second row.
That one, the other one, negative.
Okay. You had to do
Oh, you do that thing.
this one. Yeah. That thing. You good? Would you guys like to try number 2? Yes? Okay. I want you to try number 2. I want you to check with your neighbor after each step. Okay? So make your matrix equation. Check your neighbor. Do they match? Get your determinant. Check your neighbor. Get your inverse. Check your neighbor. Okay? Work through number 2. All right. We're going to play popcorn. We're playing popcorn. Who wants to start off popcorn? Emmy wants to start popcorn. All right. Emmy, what is my matrix A going to look like?
9, 2, 3, 1.
Popcorn. What is my variable matrix going to look like? Look at that. Nice. Popcorn. Malik, what's my matrix B going to look like?
3 over negative 6. I mean, 3 negative 6.
3 negative 6. Yep.
Oh.
Popcorn.
Kaylee.
Kaylee, how do I set up my determinant? All right, and what did that give you? That gave us 3. Good. Our determinant was 3. Beautiful. Popcorn. Rivers. How do I set up the inverse? Mm-hmm. All right, popcorn. Taylor, what do we get when we multiplied everything by 1/3?
1/3, -2/3, -1/3.
All right, popcorn. Malik, back to you. What are we going to multiply this inverse matrix by?
3 over negative 6.
Yep.
Why did I keep
I know, I got the same answer as last time. Popcorn.
okay. So you do the thing,
Uh-huh.
and then you get negative 2 and negative 14. Or you have to solve it, and you get negative 2, negative 14.
Okay, what's 1/3 times 3?
Shoot.
It's okay. What's 1/3 times 3?
Yeah, I caught in the act with someone.
All right. So okay, let's actually.
Yep.
1/3 times 3 is 1.
Yep. And then what's negative 2/3 times negative 6?
4.
So what's that first number going to be?
5.
There you go. Now do the next one.
And then negative 3. Okay, I did it wrong. Okay, negative 3 minus 18.
Yes.
And that gives you negative 20.
Good. So we have an x of 5 and a y of negative 21. How do we do?
I got the first 2 right.
Okay. And I gave you a little hint down here at the bottom. How can you always check your answer?
I plugged it back into the
You can always plug them back in and make sure you are right. Okay? So if I did 9 times 5, right, that's 45. And then 2 times negative 21, negative 42. Oh my gosh. Come on. I don't know. Okay? So you can plug them back in and make sure they work for both. Alright, you do number 3. Don't say it. You do number 3. Alright, Adam, pick someone. Popcorn.
Yeah. Oh shoot. Yeah, I'm picking you, boy.
Alright, set up the matrix equation for me.
4, negative 6, negative 10, 15.
Popcorn.
Taylor.
Taylor, what's the variable matrix? Yep. Popcorn.
Jake.
Jake, what's my constant matrix?
9 and 8.
Good. Popcorn.
Langston.
Langston, how do I find the determinant for matrix A?
Multiply the numbers and then
What numbers?
4 and 15 and negative 6 and negative 10.
All right, what did that give you?
16 minus 60.
Which is what?
0.
0. Popcorn.
We're done.
Popcorn.
Don't popcorn.
Adam, what does that mean?
That means that there is no solution.
Good, there's no solution. Adam, what does that mean about my lines?
That they are parallel.
Good, nice. These were parallel lines, so they did not cross over each other. We good?
Yeah.
Last one, we got this. I'll give you a second, you work on number 4. Some of you have already started, so I'll give you a chance to finish. Make sure you're checking with your neighbor. All right, number 4.
Let's go to Jacob.
All right, Jacob, what is my matrix equation? What's matrix A? What is it? All right, popcorn, please.
What?
What is my variable matrix?
Oh, X and Y.
Popcorn.
Colin.
What is my constant matrix?
2 and negative 1.
2, negative 1. Miss Allen. Thank you. All right, Colin. Miss Allen, how do I set up the determinant?
Negative 3 times negative 1 and 1 times 4.
And what did that give you?
Negative 1.
All right, popcorn to someone.
Other Adam.
Other Adam. How do I set up my inverse?
1 over negative 1
Mm-hmm.
times negative 1, negative 4, negative 1, negative 3.
Good. Popcorn.
Jimmy.
Jimmy, what does that give me?
It gives you 1, 4, 1, 3.
Good. Popcorn. So we're going to take this guy. What are we going to multiply it with? 2, negative 1. Popcorn. Griffin, so what does that give me? Careful, it's 1 times 2, and then 4 times negative 1. It'll be 2 minus 4, which gives me...
No wonder.
What's 2 minus 4? Alright, popcorn. Huh? Jimmy, what's my y? Negative 1. Alright, did we get negative 2 and negative 1? Yes? Feel good about it? So again, what are we going to add to this tomorrow? Words, which means we're going to have to do what tomorrow that we didn't do today? You're going to have to create the equations to solve. Yes?
For the last step, you're trying to figure out like the negative 2, negative 1.
Yeah.
When it's all positive numbers, what's their original subtract?
You always do what the sign is. So like when you multiply, it's not always add, it's not always subtract. Yeah, it depends on what that other sign is. Yep. Yep. So, hey guys, he just asked a great question. Determinants, you always subtract. When you multiply like this at the very end, you do what the second sign is. So here we did 2 minus 4 because 4 times negative 1 was negative 4. Does that make sense? Okay. Over here, we added because we had 4, 1, and then positive 4. So we added. So we're all determined on the second number, whether you add or subtract. Okay, determinants, though, will always subtract. Good question. All right, lovelies. So you are going to work on page 798, 17 through 22 all. There are 6 of them. Please do them on your own paper. You know tomorrow we will trade and grade and turn them in.